Good evening, everyone. Our talk session will start shortly. Nitya ma'am, is it alright if I start the meeting now? Good evening to one and all present, respected speaker and fellow students. A warm welcome to our online pre-event talk session today. I'm 𝘠𝗔𝗔𝗈, your host for this insightful journey into the world of signal processing. It is a pleasure to have you all with us. Without further ado, let me introduce our distinguished speaker for today's session. Joining us is 𝘸𝘢 𝗔𝗺, a brilliant design engineer specializing in signal processing at Aadyah Aerospace Private Limited, Bengaluru, Karnataka. With her extensive expertise and innovative insights, she's here to shed light on the captivating topic of signal processing, unlocking the potential. Ms. Hridaya, this stage is all yours. We eagerly await to delve into the depths of signal processing and discover the remarkable possibilities it holds. Over to you.
Hello, am I audible?
Yes, ma'am, you're audible.
Yes, ma'am.
Okay. So thank you for this great introduction. So as you all are from electronics background, let me know everybody is from electronics, right?
No, ma'am. Some are from computer science, electrical department also.
Okay. Are you all from for final year or every years are mixed up here?
Every year is mixed up. Hello.
Okay, fine, thank you. So let's begin. I will share my screen.
Yes, ma'am.
Hello.
Yes, ma'am. Yes, ma'am.
Am I audible? Is my screen visible?
Yes, ma'am.
Sure. Okay. So we can begin. So I'm Aadyah TV. I'm working currently in Aadyah Aerospace Private Limited as a design engineer signal processing. So basically, I'm from an electronics and communication background. I did my master's in signal processing and my bachelor's was in electronics and communication engineering. So basically, I want to give an idea that signal processing is one of the opportunities where other branches can also be included, whereas computer science for coding kind of things, whereas electronics and electrical. Mostly electrical and electronics will be having common papers. In that, the most important common paper is digital signal processing, which we are currently learning. So this is a basic idea, and I will, in my further coming sessions, you will be understanding more about signal processing. So here in this particular session, I will be stressing on to a particular area, which is related to space. So as I'm working in space, I want to know regarding the opportunities in space industry. Even though we are all working, we are all studying electronics and communication or computer science or anything, we are just in a boundary where we are not able to cross the boundary. So this is a way where we can learn more about the opportunities of signal processing as well as many other design aspects. So let's begin. So everybody will be aware about Chandrayaan 2, right? So let's make the session a little more interactive. So I want feedbacks from your side. Are you all aware about Chandrayaan 2? Hello? Hello, is there any software glitch or something?
Yes, ma'am. We are aware.
Aware. So what you know about Chandrayaan 2 and Chandrayaan 3? What is the difference between that? Why we launched Chandrayaan 3? Why what happened to Chandrayaan 2? Any idea you have? If you don't have any idea, be open. There is no issues. Let's open up. I hope nobody is aware about it. So I will say something about Chandrayaan 2 and I'll begin the session.
Ma'am, some
So,
are replying in the chat.
actually, I'm not looking onto the chat box actually. I'm just focusing on my screen.
Somebody replied that Chandrayaan 2 has crash landed on moon. So, and
Okay, so you are telling that Chandrayaan 2 is a complete failure?
no, it's like uh, soft landing was not being implemented properly.
Okay. Yeah, it's a correct answer only. So I want to make sure that Chandrayaan 2 is not a complete failure, it is a partial mission failure. So everybody, including me, was having a perception that Chandrayaan 2 was a complete failure, but it's not like that. So for every satellite, if we are launching a particular satellite, it will be having its own mission. So basically, for achieving its mission, it will be having several components. For example, Chandrayaan 2 was having orbiter, then it was having a lander, that is our Vikram lander, then it will be having a rover. So what happened is that the satellite was deviating from the trajectory and it was not able to detect the deviated path and was not able to correct it. Because of this issue, as well as the propulsion system's inefficiency, some issue happened and this was creating issues in the soft landing and it made a hard landing, we can say like that. So just before reaching the destination, the satellite was having some issue, and basically it is defined as 17 minutes of terror. So what happened is that in the case of Chandrayaan, what happened was the soft landing was not achieved due to the lack of algorithm efficiency, we can say, or software glitch, we can say, or we can say propulsion systems inefficiency. That was, if we need some amount of fuel, more than the required amount of fuel was injected, and this led to the velocity control into out of control. So this was the basic idea of the issue happened in Chandrayaan 2. So what is the importance of signal processing here? I will say in the coming parts, I will explain why I told this particular thing. So basically, what is signal processing? According to you, what is signal and what is signal processing? If anybody is replying in chat blocks, please somebody dictate it, okay? So what is signal and what is signal processing? Basically, all the data or information carrying things, which is a function of time or space, can be defined as a signal. So basically, what a signal processing engineer does is that we will be analyzing this particular signal, we will be manipulating, and we will be interpreting the pattern of the signal. So basically, what a signal processing engineer does is this. We will be extracting a set of data, we will be analyzing it, we will be manipulating it, we will be modifying it, filtering it. Sometimes the signal will be having some issues, so we will be modifying it, filtering it. Those things are associated with signal processing. So in signal processing itself, there are many sub branches where you can focus on. So in your engineering curriculum, you will be studying a lot of subjects. Example, digital signal processing, digital image processing, speech processing, audio signal processing, pattern recognition, biomedical signal processing, radar, communication, adaptive, and statistical signal processing. Few among this will be an elective for you people. I don't know which are the main subject which is mandatory. When I was doing my BTech and MTech, digital signal processing, image, and statistical signal processing was very important. I don't know which are the domains currently people are focusing on in your curriculum. But actually, speaking to the practical aspect, digital signal processing, image processing, communication, statistical signal processing is having a very, very good role. What I am doing in my current domain is mainly digital signal processing. So I want to make sure that the importance of digital signal processing to you people. So, I do you people like digital signal processing paper, or it is just mathematics, or do you hate it? Let me know.
Ma'am, most of here are from first year, so they don't have this subject right now.
Okay, so you people are studying IEC onwards, like Introduction to Electronics, right?
Yes, ma'am.
Okay. Uh, 1 second. So, basically, in electronics and communication, we will be having definitely many subjects of electronics, whereas some other branches subjects also will be there. So, whereas when we are completing our second year, then we will be focusing mainly on electronics alone. So, in that particular thing, you will be coming across these particular subjects in which in digital signal processing, you will be learning more about filters, how filters are being designed, and those particular things. So, since you majority of you are first years, I will tell you why filters are used, what is the impact of it. So basically, you know sensors, right? I'm taking an example and telling to you. So sensors, you will be coming across many kind of sensors around you. Everybody will be using mobile phone, right? So inside the mobile phone itself, there are many sensors. So this, what does a sensor does? What does the mobile does with the sensors? The sensors will give you some kind of information, and this information will be having some kind of noise or interruptions. In electronics terms, we will say noise, white Gaussian noise, like that we will be speaking. So basically, if we are speaking, the sensors data will be having a lot of irregularities. So what filters does is that we will be taking all the signals and we will be putting into some filter, and the filter will give you filtered output. This filtered output will be a smooth wave. How it will be like, for example, the raw signal what you are getting from sensors will be some kind of ECG signal. It will be like a high spike, low spike, then it will be having intermediate spikes like that. So we will be removing the very high spikes by using the filter. That is a basic idea. So if there is a very big, huge irregularities, what we will do is that the top and the below very high spikes we will be removing and makes the signal more smoother. This is what a filter does. So those kind of filters are having many kinds like IAR, FIR, that is finite length, then infinite length filters, those things. So these kind of filters are being studied in this particular subjects. It is very much having the impact in industries. So not only in satellite or space industries, but also in mobile communication as well as many other core electronics companies will be also having digital signal processing engineers vacancies. Then coming to the next part, that is image processing. Image processing means speech processing, audio processing, or data processing. Image processing, speech processing, audio processing, or data processing. Image processing, speech processing, are together clubbed, and it will be as well as aspect of this is being utilized in machine learning nowadays, robotics, automation, machine learning also. So all the signal processing techniques can be done in machine learning based automated technologies also. So the next, pattern recognition. Pattern recognition is nowadays also included in curriculum, I guess. Maybe it is an elective for you people, I don't know. So pattern recognition is also a kind of subject which is a part of signal processing. So if you are knowing these subjects are a sub part of signal processing, then you can focus mainly on it. When I was completing my BTech, I didn't knew that I will be coming into signal processing. So I hate digital signal processing paper actually, because when I was studying, it was completely mathematics. Mathematics is in a sense means different kinds of algorithm like butterfly algorithm like that. So I didn't knew that this was having this much impact. But now I love the subject, and uh, since I'm working in it, I feel like the students must also come into a picture where you should understand this subject is having very big impact in our real life. Wherever we are using digital equipment, we should understand there is some kind of signal processing happening behind it, and there is some kind of filtering happening behind it. So it is actually a beautiful area where we can explore much more. So moving on, why is signal processing important? Well, When I was beginning the session, I told regarding the Chandrayaan 2. What happened to Chandrayaan 2 was the Vikram lander was not able to establish a communication with the ground station. What is ground station? What is those things and all? You might be thinking it is very difficult terms for you people. Whenever we will be launching satellites, we will be establishing a communication. That is, someone far away from us, we will be establishing a communication through mobile, right? Similar to that, through signals, radio frequency signals, or we can say some kind of signals. I'm not going into the terminologies, but basically, to communicate something from space to the land, we will be having some kind of establishment. That is done through signal processing aspects. So basically, that path of signal was interrupted, or the Vikram lander was not able to establish a path between the ground station. That was a major issue. That was a final effect actually. But why this final effect happened is because they identified some issue was happening in the satellite, but they were not able to rectify it. So why this rectification, error detection, those part actually failed. Because of that, the Vikram lander was not able to establish its communication. That is why Chandrayaan 2 was announced as a partial mission failure, because the orbiter is still active, but the next parts were not able to function. That is why we are saying Chandrayaan 2 was a partial mission failure. So, why I am stressing this, because you want to take an example and then you have to analyze what happened to it and why this happened and how to rectify this. In an industry, if you're working in an industry, the first thing what you will be doing is that if a client comes to you and tell they want something, you will be analyzing what the end product is, where they are going to use this particular product, and to achieve that particular product, what and all things should be done, and how much failure will be there for this product, and what kinds of failure will be there, and how we can rectify this. These things has to be kept in your mind as an engineer. So, as a signal processing engineer, it is very important that you should be aware about the electronic side of the design as well as the signal based design also. In the signal based design comes the programming part. There, we can use different kinds of languages in order to establish our theory or algorithm. So basically what I do in my company is that I will be designing an algorithm and I will be passing it to a person who is coding it. So as a team, there will be a person who will be coding, that is a software team will be there, whereas a signal processing team will be there, as well as a hardware team will be there to realize this. So there comes the role of the electronics as well as a computer science team. So basically, if you are going to establish your career in signal processing means, you should be able to understand the issue properly, that is a problem explanation you should be able to know, and the solution you have to design. So why signal processing is important? Let us come back. Because due to the loss of signal, due to the loss of communication, error detection failure, data path interruptions, and failures of the components in the design will be resulting in the final failure. So in order to ensure that the final product should not fail, we will be establishing certain algorithms in order to detect the failures as well as to overcome it. That is a major role of a signal processing engineer. Moving on, where the signal processing is applied. Basically, as I mentioned earlier in the I guess it is in the second slide, I have mentioned many sub branches of signal processing. In that, I was not including sensor networks. So here I want to speak more about sensor networks. So as you all know, there are different kinds of sensors around you. The sensors will be giving you some kind of data, what it is sensing. For example, what does a temperature sensor does? It will be detecting temperature around it. What does a pressure sensor does? It will be measuring the pressure value. What about the accelerometer sensors? Do you know about accelerometer sensors? Do you know about gyroscopes, any magnetometers, any kind of sensors other than temperature, pressure and all? Water level sensors, many kind of sensors are there around you. Have you ever worked with it, or are you curious about knowing more about sensors? Let me know. Is there any answers? Am I fast?
No, ma'am, there is an answer. Uh,
Sure.
Gyroscope is very important, and space shuttles, right? Like Akshay said.
Okay. Do you know about accelerometers, magnetometers, and all? The persons who are using mobile phone should be knowing that the inside a mobile phone there will be gyro, there will be magnetometers. Those things you should be knowing. You should be having a curiosity to know what and all things are in front of you, and in front of you, if some equipment is there, how it is being processed. So as an engineer, you should be having that curiosity. So let me move on with more about sensor networks, because sensors are having a very good impact in the signal processing domain. Basically, many opportunities are concerned with communication, image processing, speech, biomedical, radar, etc. Everywhere signal processing domain is having its own importance, but people forget to speak about the sensor networks, where signal processing is also having its importance. Generally, all the sensors are being developed with the technology of VLSI. VLSI is a all you will be learning VLSI subject, or low power VLSI, high power VLSI, like subjects will be there for you people. So VLSI is one subject in which you will be studying regarding the manufacturing of the sensors or components, like that silicon based components, germanium based components, how doping is done, like that. N type, P type, like that, electrons, holes, those things and all will be learned by the subject VLSI. If a person is designing a VLSI based a chip, something IC, or something they are designing, means the signal out of that chip should also be monitored. So we are the persons who will say that I need a signal which is having this particular parameters. So that is mainly associated with the signal processing engineer. So basically, if any component what you are seeing is being in the market, means there are many people behind it. So one among them will be the VLSI engineer, one among them will be the hardware design engineer, then comes the signal processing engineer, then there will be a software team for that. So basically, these are the major parts where the job currently is associated with. Nowadays, I think IT industry is very much relevant, whereas uh, more, I think nowadays this kind of hardware design, those opportunities are also being increased. When I was doing my graduation time, I didn't in our college, the IT companies were coming mostly. We didn't have much core companies like electronics based companies. Only some companies like VVDN, Quest Global, UST, like that, few companies were focusing on this. But after doing my masters, only many core companies I came to know about more core companies. So I will, in my last part of the session, I will be focusing on which companies are there where you can apply. If you are interested in this particular area, which companies you should focus on and what you should focus on. So since you are majority are first years, means you are starting your career to become an engineer. So where you should focus, I will be telling to you. So if you love to learn electronics and communication, then one area where you can establish your career is communication engineer. It can be mobile communication engineer or satellite communication engineer. Mostly in space industry or aerospace industry, aeronautical engineering or aerospace engineering, those departments are mainly getting hired. But apart from that, keeping apart it, we can say that to design a particular satellite, they want a communication engineer, they need an electronics engineer, they need a person who codes very well, that is a software engineer, as well as they need a signal processing engineer. So these are the major parts of a product. So when you see a particular launching of satellite or something you will be seeing in your computer or TV or somewhere, you should know that how many people are working behind the success of a particular thing. One among that will be the communication engineer. So what are the major roles of the communication engineer? I will be telling to you. Basically, in one subject called as you will be learning modulations, demodulations, error detection, correction, filtering, those things. So what is modulation, demodulation? I will tell you. So basically, if you are sending a signal, you will be having a transmitter, you will be having a receiver. So a signal is being transmitted from the transmitter to the receiver. So what it does is that when a signal is being transmitted, it will be the message signal. This message signal will be carried from the transmitter to the receiver by a carrier signal. So we will be using the carrier signals to encode our message signal. So or else we can simply say that our message signal will be protected inside the carrier signal and we will be sending it. That method is known as modulation. Then what is demodulation? So at the receiver end, we will be having a signal, our own signal, original signal will be having an envelope. That removal of envelope methodology is known as demodulation. Then the next domain of the communication engineer is error detection. So, if you're sending a signal, there will be a lot of error coming into that. So, to identify the error, there are many methods like parity check, redundancy, cyclic redundancy check. Those things are there. So, though identifying the error and detecting the error, identifying the error as well as correcting the error is a major role of an engineer. So after correcting it also, the signal will be having some high sensitivity value. Sensitivity means if I'm speaking, it will be changing along with my voice modulations. So in order to overcome that high and low modulations, we will be using filtering and channel equalization. So, since you people are not much aware about the terminologies, I want to tell you is that when you complete your final year, definitely you will be thorough with this particular terminologies. But before going for an interview as a position to a communication engineer, this particular things you should be thorough with. Definitely, these will be the questions asked for that particular interview too, which I have already attended many interviews regarding communication engineer role and all. This was a major questions they will be asking to us because these are the basics. Then comes the signal conditioning designing. I'm currently doing signal conditioning designing as well as analog circuit design. As an electronics engineer who has done his bachelor's in electronics and communication or electrical, we will be hired to a position where we are hardware design engineers. So if we are a hardware design engineer, we have to design circuits. Whatever you see in front of you, like a laptop, a mobile phone, whatever be, there are many circuits inside it. So designing circuits is a very key role of an engineer. After that, the signals generated from this also is to be analyzed. For that, you can specialize into signal processing domain. So this is a basic idea. Whenever you design something, out of that particular thing, some signals will be coming. That signals also should be monitored. Then comes the role of a communication engineer into frequency band allocation. If I am speaking or if I want to launch a satellite, I should be allocating a frequency for communication to it. For every satellite, the particular company who is launching it will be acquiring a frequency band for it. Then there will be antennas. They will direct our signals into a correct path that is being forming. Then through many multiple access techniques, we will be accommodating the signals in different frequency domains, time domains, etc. Then we will be using synchronizations. Synchronization is to make sure that all the signals are within the time duration what you have sent. So basically, if you are applying for any communication perspective roles in any domain, whereas satellite or mobile communication, both you should be thorough with this particular terminologies. Then comes the video image processing process. in case of satellite. Basically, as I told before, image processing is a domain where you can begin a career with if you are very much interested. So if you are interested in this particular role means you have to study digital image processing paper very thoroughly in your curriculum. So if you have very basic, very good, thorough knowledge in that means, then definitely you will be getting hired to this particular position where you have to do remote sensing and earth observation, cartography and mapping, disaster monitoring management, agriculture management, natural resource management through the aid of image or videos. So you will be getting some images which are captured by the satellite. You will be analyzing it. You will be modifying it, enhancing it, then processing it. All this will be done by this particular role. Then comes into the sensor networks. So as I mentioned earlier, sensors are very basic components used in a device. For a sensor, first thing what we should do is that as a electronics or whatever be, whichever role you are into, if you are a signal processing engineer or if you're a communication engineer or whatever your role be, if you're put into sensor networks means, then you should be able to do the following things. That is, first is data acquisition. So basically, you will be aware about Arduino boards, then you will be aware about Raspberry Pi. Data acquisition of the sensor can be done by those devices also. We can use any microprocessors, microcontrollers to acquire the sensor data and we will pre-process it. Then we'll be doing noise reduction, filtering, and if we want a particular data alone, we will be extracting it. If we are getting multiple sensors data, we will be doing a fusion. Then we will be analyzing and anomaly, we will be checking. Then if there is a particular pattern for it, we will be following that. Why we do pattern recognition is that if I have 10 sensors with me, I will be plotting the graph of the sensors or the behavior of the sensors. So I can say that any sensor of the same batch or same kind will be having similar pattern of parameters. So for that only, pattern recognition is being given more importance. So let us analyze deep into sensor networks again. So what is data acquisition and pre-processing? Generally, data acquisition means we will be acquiring the data from the sensor. That is, if I have a sensor with me, I will be programming in such a way that the sensor should give me data in every 1 millisecond, 2 millisecond, up to 20 millisecond or anything. So I have a sensor with me. For example, I have an accelerometer which will be giving you acceleration values in 3 different axes. So basically in 3D means there will be X, Y, Z axes. So you will be getting acceleration in one axis, two axis and third axis. So what a data acquisition do is that I am gathering information from the sensor in every 20 millisecond. For configuring that, what will be the sampling frequency given is that 1 by 20 millisecond, that is equal to 50 hertz. So you know about frequency, right? Frequency, time period, wavelength. These and all are the basic things you will be studying in your first year. So what is frequency? According to equation, it is 1 by t. So here sampling rate means some kind of time. So sampling time is the 20 millisecond what I'm speaking. So what will be the frequency? It will be 1 by 20 millisecond. That will be 50 hertz. Fine. Are you getting me or am I too fast?
No, ma'am. We can understand.
Okay, thank you. So data acquisition means we will be configuring the sensor in some particular manner in which the sensor is able to produce data in a specified time. That is a data acquisition part. Then comes to the type of data-based conversions. If I am getting some analog data means kind of sine wave kind of thing. If you're getting voltage or current output from a sensor means it is an analog sensor. If you're getting digital values, whereas ones and zero representation or some kind of digital values in computer screen, then it is a digital system. If you get directly digital values, no need of ADC there. But if you do not have digital values, means you have to convert the analog into digital for further processing activities. So basically, if you manufacture a sensor, if you are making a sensor by your own means, inside the sensor there will be an analog to digital converter, because whatever data we will be getting will be in analog format. So we have to convert it into digital. That is the second method. Third method is signal conditioning. If I'm getting some data which is very few millivolts, like you know what is voltage and current, right? So if I'm getting some millivolt output from some sensors, means what will be there? I cannot feed this particular data into the processor, because processor minimum requires a 3.3 volt, or I will say it requires more than 3 voltage for recognition of the data. Below 3 volt, whatever signal comes, the processor will be thinking it as a noise. So what we should do is that whichever signal we will be getting, if it is below the threshold value, we will be amplifying it, filtering it, and then we will be achieving the accurate measurement by calibration. So what is calibration is that if I am reading some sensors voltage value, or I am, for example, what I will say is that I want to measure some angle. So for that, I'm using an inclinometer or a sensor, angle sensor, I will say basically. So this angle sensor, when I kept it 0 degree, it is showing some 2 degree error. So what I will do is that I will calibrate the sensor such that it will be 0 degree. That is, the 2 degree error will be noted, and from all the readings, I will be reducing the 2 degree value. Hope it is clear. So that is a major idea of calibration. Calibration means we will be making the device more accurate by understanding the error at the null condition. That is mainly the method of calibration. You do not want to go deep into that. So basically, the third step is signal conditioning, which involves amplification, filtering, and all. Next comes the time synchronization. In time synchronization, we will be using several protocols. Basically, this will be done by embedded system engineer or a software engineer who will be focusing mainly on network time protocols, precision time protocols, then GPS-based synchronization, etc. Then comes the data pre-processing. Data pre-processing means if any further noise is involved, we will be removing the noise. Or else we can say that if there is a signal which will be giving you continuously 2.1 volt, but suddenly there is a 3 volt spike and minus 3 volt spike. So we will be detecting the outlier and remove those high values, and we will be giving out a simple, smoother way. That is done by the team of data pre-processing. So basically, these are the major roles associated with data acquisition and pre-processing. Then comes the post-processing. If your data is very big storage value, then we will be compressing it. Then if you have multiple sensors data, we will be doing sensor fusions. That is, if I have 5 sensors in front of me and I am gathering information from the 5, then I have to do some method called as fusion. It can be any algorithms like Kalman filter, extended Kalman's filter, or anything, or else I can go for mean, median, averaging, any method. So that is basically data fusion. Then comes the analysis and interpretation, which is done by using any tools. So basically what I am using in my particular company is MATLAB and Desmos. So Desmos is a free software where students can also get into that. So I prefer you people should start using Excel sheet, Desmos, MATLAB, and Python. Python is a very user-friendly language where you can use Google Colab, Jupyter Notebook, or anything to code. Basically, now in Google Colab, there is a feature from AI that is, if you type the problem, you will get the code. But instead of using that particular feature, you can import your own libraries and you can start coding. So basic things you have to learn is that how to design a filter, digital filter. So after the session, at least you have to try at least one small filter, any low pass filter, any Butterworth filter, high pass filter, anything in Python notebook, and try it. If I get some codes, I will share it with you. Okay. So try doing those things from the beginning itself, so that when you start your career, there will not be any hindrance in front of you. Easily you can tackle the problems in front of you. So tools mainly used in signal processing is MATLAB, Octave, Python, TensorFlow, LabVIEW, C++, and many other software. For analyzing, you can use either to plot the graph and all, you can use either Excel sheet, you can use Desmos, you can use anything you can use. But basically, I will prefer you people to use MATLAB or Python itself for analyzing the data as well as for processing the data. So this is all about the signal processing domain, what and all things you should do, which and all things you should stress, like that. So basically, as a signal processing engineer or a design engineer who has completed electronics and communication, definitely your opportunities is very vast. That is, you can either approach to communication domain, you can approach to signal processing, pure digital signal processing domain, sensor networks, anything. So basically, I want to tell you is that there are many companies in front of you other than the basic IT companies that we all knows. Basically, in every colleges, we will be getting hired in some IT companies. I don't want to mention a particular company, but I was selected in UST Global, TCS, and CTS. So those are IT domains where people will be giving you software related jobs, whereas I have completed my electronics. But there will be a question in your mind asking that, do I want to start my career as a software engineer after completing electronics? So this is an answer to you people. If you are ready to explore the opportunities in front of you, definitely there is a chance for you people to get into this particular domain. So with your mutual contacts or with your seniors who are working in electronics domain, you can get into this particular domain. Whereas in my company also, since it is I am working in Aadyah, where Aadyah is a startup company, but you can learn a lot of things from a startup based company, because you will be the only person to do this particular thing, so you can explore to your extent. This is my particular personal experience. So I will suggest, if you are a fresher, you should start a career with a startup company, so you can end up your career by becoming a very good consultant or anything else. Basically, to enlarge your mindset or to get more knowledge, I will definitely suggest you to go with a startup companies where you can learn much more things. So this is all about signal processing domain. So I will be focusing on few companies which is in aerospace domain, which you can apply to. That is like Pixel, Dhruva, Skyroot Aerospace, Aadyah Aerospace even, then Agnicool. Then if you are searching with public sectors means, you can go with HAL, then Bell, that is Bharat Electronics, then Keltron, VSCC, IS Aero, like that. So I don't know whether you people are interested in aerospace domain. Actually, it is a very you will feel proud if you are sitting in that particular domain, because everything is going up in the sky, whatever you do. So you can imagine that whatever you do will be having a success if you put your 100% into it. So that's all I want to tell to you people. So anything else? Any questions? Any questions you people will be having? Definitely you are open to it. What are things you should know, which companies you should apply, how your path should be. I think this is clear with this particular session. What and all subjects you should focus when you are an electronics engineer, as well as if you are an electrical engineer. Mainly which and all subject, if you focus, you will get a core job. Hope this is clear to you. So any other queries you are having, you can ask to me. No questions, or
I guess, ma'am, no questions. They are clear about it.
is the session clear to you people? Was okay. Means
Uh,
I am an IT student. I'm interested to software field as possible. Definitely, you can get into software field if you are interested. I was not personally. I was not interested into software domain because I'm not having that logic to clear the issues. So I guess my interested domain was design and signal processing. That's why I am focused into that. But definitely, majority. I guess after completion of electronics, also 70% of the students will be focusing into software domain. Definitely. So there will be companies like TCS, CTS, Bosch. Many companies are there where you can explore your chance opportunities. Definitely, you can go into software domain. But even though if you're doing software domain, um, it is better you should be able to identify your interest. Without knowing your interest and getting into a software, definitely okay, but I have supply. Definitely, you should clear your supplies before you complete your final year. Only then you will be getting opportunities, right? So it is not about having supply. No companies will be asking to you that whether you have, you were having supply. They will be having asking you whether you have any current areas. If you have any current areas, you have to clear it. I guess in my batch, a person who was having about 12 supply got a job in Bosch because only one thing was that he cleared it in one stretch. That is the basic thing what they attracted to. Ma'am, I am an EC student currently in S4. I have a favoritism towards space and stuffs and have a goal to work in ISRO if possible. So, what should I concentrate on? Definitely in ISRO, you have to concentrate only for clearing ISRO examination. You have to focus only on your electronic subjects only. There is nothing related to space. They will ask basic electronics. You are studying communication, then communication based questions will be there. Everything will be basic. So basic thing I want to tell you is that if you're preparing for gate, ISRO exam is not that tough as gate. It is only constraint is that time will be very less compared to gate exam. So if you know 60 questions which is coming in ISR exam, you will be able to answer 60, but you will not be having enough time to answer it. That will be one constraint. So if you are really willing to get a job in ISRO, definitely start preparing now itself with giving time limits to yourself. Then what else? Please mention the companies in Bangalore software field. In companies in Bangalore means there are a lot of companies in Bangalore. I mean, can I mention a particular company? There are a lot of company. Actually, I'm working in Whitefield area. In Whitefield area itself, IT Park is there. Then Manida Tech Park is there. Then Electronic City is there. So in these particular thing, like our Info Park and Techno Park in Trivandrum and Kochi, many companies will be there inside it. So if you are really wishing to establish a career in software means start searching in LinkedIn regarding to your particular interest. Then what are the key subjects I should focus in my semester subject if I'm focusing more into communication field? If you are focusing more into communication field, first of all thing is that you should clear audio electronics paper. Then if you really need a job in communication field means you should focus on microwave and radar system subject. Then advanced communication system, one is that paper. Then basic electronics, you should be thorough with basic electronics because everybody will be asking in the interview regarding the basic electronic questions like what is resistor, what is capacitor, what is inductor. Towards the end, they will ask what is modulation, what is demodulation, what you know about filtering, those things. So communication field means digital signal processing you should be thorough with. Then advanced communication system you will be thorough with. Then this kind of papers like you have statistics with in your curriculum. I don't remember. Static is there means you should be thorough with that also. Then, ma'am, I am a first year CS student. What should I do from now onwards? Any personal suggestions? If you are interested in computer science, then definitely move with your domain itself. If you really want to establish a career in public sector, like a government sector means, I don't know whether computer science is having a much opportunities in government sector, but whereas you are having a very wide opportunities in private sectors, everybody will be picking you up. soon after you complete your graduation. So there is nothing like that now. I think when after finally, or you will understand, computer science people will be highly getting paid, and those steps will be focused on IT students, like computer science students. But basically, if electronics or electrical anything, if you're going to core companies, means starting salary will be okay, but furthermore, due to if you have a good experience, then definitely you will be paid more. So if you want to go to if you want really a high paid jobs, means first mainly focus on startups, then you can learn more and get paid more. That's it. If I cleared all supplies before passing BTech, then will my certificate show those supplies? Everybody is KTU only, right? If you're KTU, supplies won't be there, but number of chances will be mentioned in your consolidated mark list. I guess so. But no companies will ask you regarding your consolidated mark list. Only they will ask you whether some companies will be asking whether you had arrears also. I don't think majority will be asking it, but most companies will be asking current arrears only. If you have cleared it, definitely you will get a job. As an ECE student, what should I choose for my minors and honors? Minors and honors. Minors, I don't know much about those things because I am a KTU batch, first KTU, second KTU batch. So I don't know. We didn't have minors, but I had honors. In my honors, I was doing secure communication, then signal processing based papers only I was taking, but I didn't knew that I will be getting into this particular domain. Ma'am, I'm an EC student. What are the opportunities in public sectors like HAL and BEL? BHEL or BEL, you will be having defense domain. So if you complete electronics and communication engineering, they will be hiring you as a contract basis initially. Then sometimes if exams comes only, you will be getting to a permanent job. HAL also contract based electronics communication engineer they will be taking. Now also they will be taking. So I didn't know. After my graduation or post graduation, there is no exam yet happened for HAL and BEL. But ISRO last few weeks ago, ISRO's exam was there. So I hope the next ISRO exam will be after 3 years, maybe. So you people will be lucky to and get into that. Any other questions you are having? Is the exam of ISRO harder than cracking GATE? Definitely no. ISRO exam is easier than GATE, but only thing is time constraint. If you take the question paper of ISRO, every questions will be able to answer if you complete your 4 years of BTech. But there is cracking GATE is a very big hurdle, I think, compared to ISRO's examinations. Then any other questions? Any other questions you people are having? Hope I have answered majority of it. Anything else do I want to clarify? And I want to make sure that you people should not focus on your marks because keep marks apart. You should gather information and you should have a practical knowledge more. So if you're studying a particular subject with respect to the application based, you should be thorough with. What exam should I approach for acquiring a BTech for ECE? What exam should I approach after acquiring a BTech for ECE? After BTech in electronics, if you are interested in teaching, there is assistant professor examination. If you complete MTech only, you can do that. Then you can concentrate on GATE, definitely GATE. Then ISRO is there. More public sector examinations, I'm not knowing much because I'm not interested much into that public sector. Anything else you want to know? If I was knowing it, I would have told you. I guess GATE is a major thing you have to focus. If you have a good GATE score and all, if you are applying for a company, you can highlight it in your resume saying that I am a GATE, I cracked GATE in this particular year with this much score, like that you can mention. Then anything else? Mainly focus on your projects. That's it.
I guess, ma'am, this is it we have a time constraint also.
Sure, sure. Even I have a meeting after 9.
Yes, ma'am. You are also busy.
Yeah, yeah. Fine. So let's conclude it. Wishing you
Hearing.
all the best for your future endeavors.
1 minute, ma'am. Uh,
That was a very interactive question and answer session. Thank you, ma'am. As we draw near to the conclusion of this enriching session, I would like to extend our heartfelt gratitude to Aadyah Aerospace Private for gracing us with her profound knowledge and insights. We would like to present Ms. Aadyah with a virtual memento. Please take this as a token of our appreciation for your valuable contribution today. And now, before we bid adieu, let's capture this momentous occasion with a group photo. Attendees, please turn on your cameras and let's freeze this moment in time with a delightful screenshot. So everyone, please turn on your cameras. Everyone, please turn on your cameras. Thank you once again for the wonders of signal processing. Your presence has truly enriched our gathering today. A feedback form link has been typed in the chat box. All participants are requested to fill out the form and provide us with your feedback. With this, we conclude today's session. We extend our sincere thanks to all attendees for their active participation. and insightful questions. Until we meet again, stay curious and keep exploring the boundless realms of knowledge. Goodbye and have a wonderful day.